This is the last problem we are solving in this chapter. This is, I said, this is chapter 16, kinematics of a rigid body, and section 3, it is rotation about a fixed axis. So let's try together and solve this problem, 1635. So guys, here we have a plate, and going through the plate we have a shaft. And these are rigidly connected to each other, meaning that if the shaft was rotating, then it will cause rotation of the plate itself. So both of them are rotating now if the shaft was to rotate. So now it says that if the shaft and plate rotates, so if the shaft and plate rotate actually with a constant angular velocity of omega equals 14 radians per second. So omega is 14 radians per second. Now it's constant, meaning that there's no acceleration. So alpha immediately is 0. So without thinking, if the velocity was constant, then there's no acceleration. So alpha, or the angular acceleration, is 0. So now we have to determine the velocity and acceleration of point C. So here we have point C located here on the plate. We need to find its acceleration and velocity, which is V and A, right? So these are not angular ones. These are normal directional velocities and acceleration. So this C is located in the corner of the plate at the instant shown. So now we have to express the result in Cartesian vector form. So how do we solve these problems? Using Cartesian vector form. We start with our main equation saying that the velocity or the velocity at point C as a vector equals the angular velocity as a vector cross R, and R is any position vector from any point along the axis of rotation, which is along this shaft, to point C. So it could be from B to C, it could be from A to C, it could be from any point on this shaft to point C. And since O is also on this shaft, so we can consider this position vector, which should be the easiest because O is the origin. Now we have coordinate system here, right? X, Y, and Z. So X, Y, and Z axes. And now we have dimensions. So now we know the dimension of point C, right? So if we go from O to C, we have first to go in the negative x direction, a value of 0.3 meters. So this is minus 0.3 in the I direction. And then we have to go a distance of, or walk, or whatever, a distance of 0.4 meters, right? This is 0.4 meters in the J direction. And we have only two components, in the I and in the J. And that's the vector formation of this vector R. Okay, so that's it. And then we carry out using our equations that we've learned in the class. So, what do we know from this problem? So this is 1635. What do we know? We know that the angular velocity is constant, and that equals to 14 radians per second. So if this is constant, then immediately we should know that the angular acceleration is 0 radians per second squared. What should we find? We should find the velocity and acceleration of point C. Okay, how do we start? We start with our equation. Our general equation says that the velocity, whatever, we are dealing with C though, equals to, so this is vector, the vector form, equals to omega in the vector form, which is the angular velocity, multiplied, or cross, sorry, this is cross R. So cross R to point C. Now guys, remember we said that we have to go from omega towards R. That's why it's omega cross R, as you remember in the classroom. So we said we go from omega towards R. That's why it's this. Just don't mix it. This is not equal to R cross omega. Okay, so omega cross R. But so now we could find R easily, right? So R was simple. R was simple. It was basically, we said that we have to move minus 0.3 meters in the I direction plus 0.4 meters in the J direction, only in the XY plane. This is in meters, right? So that was easy. Now we have to find omega. Omega anyway is also easy. So now if we need to find omega in the vector form, then we have to find first a unit vector. And remember guys, omega is not on the x-axis or on the y-axis. It has different orientation, right? So to find it to write it in the Cartesian vector form, we have to multiply its magnitude by a unit vector. Unit vector of what? Let's go back to the question. Unit vector. Now, this is omega. So the unit vector, simply speaking, so omega is going around this, so it's causing this bar or shaft, whatever, to rotate in this direction, So this is in 2D, right? But if you curl your fingers around the shaft, then your thumb would be directed in this direction, right? Going in this direction from O to A. So this is the direction of omega, from O to A. So we have to find a unit vector along this shaft, which is BO, OA, or BA, whatever. OA is also okay. So we can actually use this unit vector, OA. Now, this unit vector simply to find the direction or the components of this vector. As you remember from statics, what we need to do, simply speaking, is to find its components on the I, j, and k. So in the I direction, on the x-axis, we have to go backwards in this direction, a distance of 0.3. So this is minus 0.3 in the I direction, and in the j direction, it's 0.2 positive, and then we have to go up in the z direction, which is 0.6 in the k, right? So now, let's do that. So we said unit vector, OA. Okay? However, this unit vector OA equals to, as we said, so this is unit vector. This is minus 0.3, as we said, in the I direction, plus 0.2 in the j direction, and then we have to go up a distance of 0.6 meters in the k direction. Over the summation, the square root of the summation of its squared components. So this is minus 0.3 squared plus 0.2 squared plus 0.6 squared. So this should give us minus 3 over 7 in the I direction plus 2 over 7 in the j direction plus 6 over 7 in the k direction. But this is only unit vector OA, right? To find omega, we have to multiply this whole thing by the value of omega. So the value of omega was 14. The magnitude was 14 radians per second. So just multiply it with a value of 14. So you get omega in the Cartesian vector form equal to minus 6 in the I plus 4 in the j plus 12 in the k direction and meters per second. That's not correct. This is radians per second because this is angular velocity. Okay, that's it. So now we carry out our cross product. This is very simple, using determinant that we've learned in statics and in several math courses. We say now that BC is omega cross R. So be careful with your arrangement. Do not mix things up, otherwise you'll have wrong values or at least wrong sign. So this is minus 6 in the I plus 4 in the j plus 12 in the k cross R, and R was minus 0.3 in the I plus 0.6 in the j. So here we have I, we have j, and we have k. This is positive, negative, positive. So omega then r. So omega was minus 6, the j component was 4, and the k component was 12. And r, it has only two components in the I and j, minus 0.3 and 0.4. Oh, sorry, this is 0.4. I apologize. So this is 0.4. I hope, yes, 0.4 in the j. So and this is 0.4 and 0. So as you remember, guys, we start with the I, we cross this column and this row, and we work with these 4. So this is equal to I, so we cross these out, 4 multiplied by 0 minus 12 multiplied by 0.4. Now we work with the j, and j is negative, always remember minus j multiplied by. So cross these out, minus 6 multiplied by 0 minus 12 multiplied by minus 0.3 plus k. K was positive, it's always positive. So cross these out, you get minus 6 multiplied by 0.4, minus 6 multiplied by 0.4 minus 4 multiplied by minus 0.3. So you carry this out and you'll get BC is equal to minus 4.8 in the I, minus 3.6 in the j, minus 1.2 in the k, radians per second. And that's it. So basically this is how we find VC in the vector form. Now AC is also actually the same thing. We have another equation says we know that the acceleration of C is equal to alpha C multiplied by RC plus omega multiplied, again we are working with C, right? Omega C multiplied by omega C multiplied across, these are crosses, right? Alpha C cross RC plus omega C cross RC twice. So you just do the same thing. You just do this cross or this determinant calculations twice instead of once. So we know that this is constant, so this is 0 plus minus 6 in the I plus 4j plus 12k cross, we have minus 6 in the I plus 4 in j plus 12k, right, twice. This is cross the RC, which was minus 0.3 in the I plus 0.4 in the j. So if you carry this out, you'll end up with 38.4 in the I minus 64.8 in the j plus 40.8 in the k, and this is radians per second square. That's it. Thank you so much. Please try to carry out this calculations by yourselves and let me know if you have any questions. All right.